All right, this is 7.1 and 7.2 geometry lessons. Starting with 7.1, this chapter we're going to cover polygons and parallelograms and angles, diagonals, all of it. So starting here, let's talk about angles of polygons and diagonals. So first let's talk about what a diagonal is. So a diagonal, where is my pen? There we go. A diagonal is going to connect a vertex, so let's say B, to a non-consecutive vertex. So C would be consecutive, and so would A. So we can draw B anywhere except C or A. So we can draw a diagonal over here to D, or we can draw it here to E. So these are both diagonals. And like from D, we could draw back to B, we could draw to A. From C, we could draw to A, we could draw to E, and so on. So it just has to connect to two vertices that are not consecutive with it. So BA would not be a diagonal. It has to go to the other side. All right, so next, let's talk about interior angles. Oh, wait, I went too far. There we go. All right, so to find interior angles of a polygon, it doesn't matter how many sides it could have. It could have 4 sides or it could have 25 sides. The formula is still the same. What you're going to do is you're going to use this formula here, n minus 2 times 180. So our n represents the number of sides that we have. So what do we have for this one here? 1, 2, 3, 4, 5, 6. 6 sides. So we would say 6 minus 2 times 180. You can also count angles. Sometimes it's easier to count angles. Sometimes I tend to forget where I started, but I can usually remember which angle I started with. So if you want to count angles, you can do that too. Angles or sides, same answer. So we would say n minus 2 times 180 degrees. That would give us the total measure in degrees of our interior angles. So if we took the measure of angle 1, 2, 3, 4, 5, 6, added them all up, that's what this formula would tell us. So what is n minus 2 times 180? So 6 minus 2 is 4, right? 4 times 180, what is that, 540? So the measure of all of the angles here, let me just make sure, it's hard to do in my head. 4 times 180, nope, I was wrong, 720. 4 times 180, 720. So the measure of all of these here is 720 degrees. So if we knew them, like if 2 was 135 and 1 was 70, and then the rest of these were some variant of x, we could figure out what x is and figure out all of the different measures of the angles. So that's what we are working towards. So look at this one here. It says find the sum of the measures of the interior angles. Let me scooch this over a bit. There we go. Okay, so it's an octagon. So our n would be 8 because an octagon has 8 sides. So we would say n minus 2 times 180. We would have 6 times 180. The measure of all these angles added together in here would be 1080. A few vocabulary words to remember. The difference between concave and convex. This formula only works with convex polygons. We can't have a concave polygon. You might remember an example of a concave polygon might look something like this. Remember, it caves in. Some of our rays from our sides cross to the inside, so it's concave. Whereas a convex polygon could be anything like this. None of these cross to the interior. So it is convex. Okay. Let's look down here. Monitoring progress 1. It says the coin shown is the shape of an 11-gon. Find the sum of the measures of the interior angles. Okay, so they told us it has 11 sides. So we would say n minus 2 times 180, and that would give us the sum of the measure of the interior angles. We know n is 11, so 11 minus 2 times 180. So we're saying 9 times 180, and that is 1,620 degrees total. Now, we know that all of these 11 sides are exactly the same, and that makes it a regular 11-gon, a regular polygon. So if all the sides are exactly the same and all the angles are exactly the same, we can actually then find the measure of each interior angle. So if our total measure is 1,620, we can just divide that by 11 to get the measure of each interior angle. So it would be 147.27 degrees for each angle. All right, moving on. There we go. Finding the number of sides of a polygon. There we go. Okay, moved it a little too low. Hold on. Okay, the sum of the measures of the interior angles of a convex polygon is 900 degrees. Classify the polygon by the number of sides. Okay, if the sum is 900 degrees, we know that that's what the total angle measure, this is where it goes, right here on the right-hand side, because that's usually what we're trying to solve for. But here in this question, in this problem, they gave us the answer. We're trying to find n. So all we need to do here is work backwards. So to solve this, pull my paper up here, to solve this, we would just then, hold on, let me write it down, n minus 2 times 180 equals 900, okay? We're just going to use simple algebra. So let's divide by 180 for each side. Okay, and that equals 5. So we know that n minus 2 is 5. Add 2 to each side. So our n must equal 7. So, whoops, there we go. The polygon must be, or must have 7 sides. All right, a 7-sided figure is called a heptagon. Moving on. Here's corollary 7.1. And to recap, a corollary is like a common sense add-on to a theorem or a postulate. So our common sense add-on says the sum of the measures of the interior angles of quadrilateral is 360. We already know that. A triangle is 180, and when we add that fourth side, we get 360. So squares, rectangles, any quadrilateral, 360 degrees. Okay, moving on. Let me zoom this out a little bit more. Okay, so here it says find the value of x. Okay, if we know that this is a quadrilateral and we can tell by counting the sides, then we can see that we're only missing 1, and we know they have to add up to be 360 degrees. All you need to do is add them up and subtract from 360. So we have 108, 121, and 59. And that is, let's see, 18, 8, 330. Right, I must have added wrong. Hang on. Did I write them right? Okay, not 338. Hold on. 17, 7, 8, 288. See, even math teachers have bad days. Okay, 288. So then you can just subtract from 360. And we would say 360 minus 288, we would get 72. So x would equal 72. So you can solve that way. All right, let's try a couple. Move the textbook up. There we go. All right, look at monitoring progress number 2. It says the sum of the measures of the interior angles of a convex polygon is 1,440. Classify the polygon by the number of sides. Okay, so first we're going to set up our problem. So we know that it equals 1,440, and our formula is n minus 2 times 180. So just work backwards. Divide by 180. Okay, so we have n minus 2 equals 8. Add 2 to both sides. We have n equals 10. So we have a polygon that has 10 sides, a decagon. All right, number 3 says the measures of the interior angles of a quadrilateral are x, 3x, 5x, and 7x. Find the measures of all the interior angles. Okay, so we have, let's see, we'll do this down here. We have x plus 3x plus 5x plus 7x. And we know that it, whoops, there we go. We know it has to equal 360 degrees. So x plus 3x, 4x gives us 4x, plus 5x gives us 9x, plus 7x gives us 16x equals 360. Divide each side by 16. All right, so x equals 22.5. So what is the measure of each of our angles? So one of them is 22. How about, let's see, I'm just going to write it above them. There we go. This one here is 22.5. Then to get 3x, we would just multiply it by 3. So we would have 67.5. For this one, we would have 112.5. And for 7x, we have 157.5. So if you add all of these up, they should equal 180. So we can say 157.5, let's do that, plus 112.5, plus, all right, these two together are 270, plus 67.5, plus 22.5, and we have arrived at 360. There we go. Okay, moving on. Now we're going to talk about different types of polygons. So this right here is called an equilateral polygon. That means all the sides are congruent. And when we did triangles, we had an equilateral triangle. That meant all the sides were congruent. Here we have an equal angular polygon. This means that all the angles are congruent. And we had one of those in triangles too. That was equal angular, where all of the angles were congruent. Where they're different is that when you have an equilateral polygon, the angles are not typically congruent. Sometimes they are. They don't have to be though. Same thing with an equal angular polygon. The angles can be congruent, but that doesn't mean the sides are. Whereas in a triangle, if the sides were congruent, the angles were also. It's a little bit different here. It can be just either or it could be both. This one's both. It's called a regular polygon, and you can have a regular just about anything. A regular quadrilateral would be a square, right? Sides and angles congruent. You could have a regular pentagon or octagon or any of them. So any type of regular polygon, sides and angles congruent. Okay, let's move on. There we go. Okay. So in this example, it says a home plate for a baseball field is shown. Is the polygon regular? Explain your reasoning. Okay, so in a regular polygon, we have to have, if I can get that glare off, maybe not. We have to have sides and angles congruent. So this side here, AB, definitely looks longer than AE. So even there's no markings on the side. So automatically we cannot say they're congruent. And we can also tell just by looking that this side here is quite a bit longer than this side. Also, in a regular polygon, all the angles have to be congruent. Well, we have 3 right angles, and we have 2 angles that are definitely obtuse. So this is not a regular polygon. And then it says find the measures of C and E. So to find the measures of C and E, first we need to know how many degrees total we are dealing with for the inside of this polygon. So how many angles or sides do we have? 1, 2, 3, 4, 5. So we're going to come down here and do our formula. So we would say n minus 2, and that would be 5 minus 2 because we have 5 sides. 5 minus 2 times 180, it would give us 540 degrees total interior for here. Now we know that 3 of them are 90 degrees angles. 3 of them are right angles. So we could take 540 and we could subtract 90, 90, and 90. We could also call E and C X. So what we're left with after we subtract 90, 90, and 90, we could divide what's left by 2 because these 2 are congruent and we're splitting what's left equally between 2 angles. Another way to do it is to assign a value to each angle. So this would be X, this would be X, and these 3 would be 90. So we could write an algebraic equation that says X plus 90 plus 90 plus 90 equals 540. Subtract it, you're really doing the same thing. But here you're writing the equation, and the other way you're mostly doing it in your head. Both will work fine. So X is 135. That does make sense. This angle looks to be about 135 degrees. All right, let's try another. Look at number 4. It says find the measure of S and the measure of T in the diagram. Okay, so what do we know about this shape? We know that it has 1, 2, 3, 4, 5 sides. And we know that S and T are unknown sides and they're congruent. So how we can solve this is, there we go. We're going to assign these the same value. So we can say X plus 93 plus 156 plus 85 equals our total interior angle measure. What is our total interior angle measure? Let's find out. We have n minus 2 times 180 equals what we need to know for our total interior angle measure. How many sides did we say? 5 sides, so 5 minus 2 times 180 is going to give us 540 degrees. So up here, this has to equal 540 degrees. Sorry, there we go. All right, so now we're just going to solve it algebraically. We're going to subtract each of these and divide by 2 for our x's. So we have 540 minus 85 minus 156 minus 93. So we have 2x equals 206 once we subtracted all of those. Now we just divide by 2 and we're left with x equals 103. So each angle measure is 103 degrees. Okay, let's move on. Let's talk about exterior angles versus interior angles. So if this is our polygon here, and we were to extend in each direction, each of our sides that makes up our polygon, we would have a lot of different exterior angles per vertex, right? We would have 3, 1, 2, 3 per vertex. So we're never going to use the vertical angles when looking at exterior angles because those are going to be the same as the inside measure. So you either need to pick the one to the right or the one to the left. In this example, they've shown the angle to the left all the way around. So it just has to be consistent to get your exterior angles. The nice thing about the exterior angles is that they all add up to be the exact same thing every single time. So the sum of all exterior angles is always 360 degrees. So on this shape here, if we added 1, 2, 3, and 4 together, we would get 360 degrees. On this one up here, we would also get 360 degrees. It never changes. No matter how many sides you have, it's always 360 degrees. Let's look at this one. Here they've given us some of the angle measures of the exterior angles. And it says solve for x. So we have 4 here. Well, these 4 are going to add up to be 360 degrees, just like all of them. So your algebraic equation to solve for this would be x plus 2x plus 89 plus 67 equals 360 degrees. Subtract out your 89 and 67, combine your like terms, you get 3x. And then down here, if you divide out by 3, you get x equals 68. So the value for x is 68. Then you can solve for these two angles. Let's look at another one. This one says the trampoline shown is shaped like a regular dodecagon. How many sides does a dodecagon have? That's 12 sides. Find the measure of each interior angle and find the measure of each exterior angle. Well, the exterior angles are the easiest ones to find. So thinking about that, we know that the exterior angles are always 360 degrees, right? And we know it's regular. That means, right here it says regular. That means all of our interior angle measures are congruent and all of our sides are congruent. So if all of our interior measures are congruent, all these little segment extensions we're going to draw off here are going to create exterior angles that are also congruent. So we can just divide 360 by 12 and get each exterior angle. So each exterior angle is 30 degrees. So now we need to look at, excuse me, each interior angle. You have a couple choices now on how to solve, but we're going to go through all of them just so that you understand all of them. Excuse me. Okay, so we can use our formula to find the total measure of our interior angles. So we can say n minus 2 times 180, plug in our 12 there, and we're going to get 1,800 for our total measures of our angles. Now we know that this is regular, so each angle is going to be exactly the same. So then we would just divide by 12. And we would get 150 degrees. So see, this is our exterior. This way, here we go. And 150 degrees is our interior. Now, what do you notice about these two measurements? If you combine them, they equal 180 degrees, right? And the reason that is if because I extend, I'm going to draw on the book. If I extend this right here, what have I created? I've created a linear pair with this little exterior angle and this interior angle. They add up to 180. That's why your exterior angle and your interior angle will always add up to 180. So we didn't even have to go through this whole part right here. We could have found our exterior angles. It's 30. Since it's a regular shape, we know that this has to be our linear pair and that each one's going to be the same. So we can just say our interior angles are 150 without even having to calculate anything. That only works with regular shapes. If you don't have a regular shape, it's not going to work. Okay. If you don't have a regular shape, you will have to do the formula for each one. Okay, let's move on. Hold my paper the other way here. Okay. Monitoring progress number 6. A convex hexagon has exterior angles with 34, 49, 58, 67, and 75. What is the measure of an exterior angle at the 6th vertex? Okay, we have 1, 2, 3, 4, 5 angles given. We're missing a 6th angle. We know it's a hexagon, so it has 6 sides. So all you do to find the missing exterior angle is add all these up and subtract from 360, and that's what we'll be missing. So let's add them up here. 34 plus 49 plus 58 plus 67 plus 75. So 283. So now we're going to subtract from 360. And our missing angle measure is 77 degrees. Okay, that's it for 7.1. It's an online assignment and it's up. Let's move on to 7.2. Okay, in 7.2, we're going to talk about parallelograms. Okay, a parallelogram is a quadrilateral with both pairs of opposite sides parallel. So here we have this quadrilateral, and these two opposite sides are going to be parallel, and these two opposite sides are going to be parallel. That's what makes a parallelogram. So the first theorem for this section is called the parallelogram opposite sides theorem. So this one says if we have a parallelogram, so we have to know that it's a parallelogram, okay? Then not only are opposite sides parallel, they're also congruent. So here QR is going to be congruent to PS, and SR is going to be congruent to PQ. The next theorem says parallelogram opposite angles theorem. So now we know that we have opposite sides parallel, opposite sides congruent. Now our opposite angles are also going to be congruent. So if you were to think of this as, I thought there was a good example of it. Maybe not. If you were to think of these opposite sides, let's just take QR, okay? We're just going to draw QR and that's it. Okay. So we have QR, and then this one down here would be, let me move this over here, would be PS. Okay. And we know that these are parallel. Okay. If we were to draw a transversal, let's say we draw the RS transversal like this, it would actually be a true transversal, okay, which means that these are going to be supplementary and these alternate interior angles would be congruent. And then we draw another transversal that is parallel over here, QP. That means that these are congruent and then our alternate interiors are congruent. That is how you get opposite sides, opposite angles to be congruent. So with parallelograms, everything is opposite. So opposite sides congruent, opposite angles congruent. So if you have trouble remembering it, just think of your two sides as transversals. Then you can mark all of your congruent angles. That will help you remember. Okay, let's move on. Let's look at one. All right, it says find the values of X and Y. So here we have a parallelogram, and we know it's a parallelogram because we have parallel lines marked, two sets of them. So we know our opposite sides are congruent. So AB would be congruent to DC. So we can solve for X by saying X plus 4 equals 12. We can also solve for angle y by saying angle y is congruent to angle C, which is 65 degrees. Excuse me, because our opposite angles are congruent. Okay, let's try this one. Find FG and the measure of angle G. So FG, we have two opposite parallel sides. So we know we have a parallelogram. So if HE is 8, that means FG must also be 8. And that means our opposite angles are congruent. Therefore, if angle E is 60, angle G must also be 60. The same is true over here. We can say 50 degrees equals 2x, and we can solve for x that way. And we can say y plus 3 equals 18, and we can solve for x that way. If you think back to chapter 3, we have the consecutive interior angles theorem. And that says if you have two parallel lines, your consecutive interior angles are congruent. So just like that, if we were to add another line and make it parallel to this one right here, this is how this relates to parallelograms. Our consecutive interior angles are also congruent. So angle K, not congruent, supplementary. So angle K would be supplementary to 2x. Which brings us to our next set of theorems. And it says parallelogram consecutive angles theorem. If it's a parallelogram, then consecutive angles are congruent. So supplementary. So our opposite angles are congruent and our consecutive angles are supplementary. They equal 180 degrees. We have 180 degrees here. We have 180 degrees here. It's a quadrilateral, so it all adds up to 360. Our next theorem is our parallelogram diagonals theorem. And what this says is if you have a parallelogram and you draw diagonals, so I would draw from P to R and create this diagonal, and I would draw from Q to S and create this diagonal. They're going to intersect at a point, and the place of intersection is going to bisect each angle so that this side is going to be congruent to this side, and this side here is going to be congruent to this side. So the diagonals bisect each other. They're not all four congruent, they're only congruent to the opposite one, to the one they're bisecting. Okay. Let's see. Here we go. It says, as shown, part of the extending arm of a desk lamp is a parallelogram. Right here, the spread part, A, B, C, D. The angles of the parallelogram change as the lamp is raised and lowered. Find the measure of BCD. BCD. So this little angle here is what we're looking for, right there. Angle C. When the measure of ADC is 110. So this uses the consecutive angles theorem. So if this one is 110, that makes this one here have to be 70 because they are supplementary. All right, let's move on. Parallelograms in the coordinate plane. If you have a parallelogram in the coordinate plane, there's many things that the questions for the homework could ask you. One thing they could ask you is for coordinates of the midpoint, or coordinates of the intersection point of your diagonals. So they're going to start by giving you some points here to plot. So plot your points, then take your straight edge and draw your diagonals. And then it wants to know the intersection of the diagonals. Well, as you can see, this is in the middle of something. So to find the exact intersection, you can just choose one diagonal and do the midpoint formula for it. You don't have to do it for both. If you do it for both, you're going to get the exact same thing because they intersect at the same place. So their midpoints are the same. That's the intersection. So we could do here in the example, they did the midpoint of OM. So they did x1 plus x2 divided by 2, y1 plus y2 divided by 2, and they got 7/2 and 2. So your intersection point of your diagonals is 7/2, 1, 2. I mean 7/2 and 2, sorry. Okay. Here, it shows you how to find the missing vertex. So if they tell you you have a parallelogram and they say find the coordinates of the missing vertex, excuse me, this is how you would do it. Let's say they give us x, w, and z, and we are supposed to find y. So plot x, w, and z. Then what you're going to do is find your slope from w to x, because that's the same thing you're going to need to do to go from z to the missing vertex, right? Because they are parallel, so they're going to have the same slope. So we can just do one step and find it that way. So what's our slope from w to x? We went up 5 to the left 2. So our slope was -5/2. So right here, we're going to start at z, and we're going to go up 5 and to the left 2. And right here would be your y coordinate, 2, 1. So if we were to draw it, we would have our parallelogram right there. So let's try one. Look at number 5 and 6. We're going to do both of them. So 5 says, find the coordinates of the intersection of the diagonals of parallelogram STUV. Oh, and this is how you draw the little parallelogram symbol. You just draw a tiny one. Just make sure it doesn't look like a rectangle. And it gives us these 4 vertices. So we're going to start by plotting them. Okay, here we go. Let me zoom out a little bit. Okay, so we're going to plot them. Here's S, T, U, and V. Plot them here. Take your straight edge and draw your diagonals. Okay, their intersection point is where your 2 diagonals are going to intersect. Now we can do midpoint formula for one of these diagonals and get these 2 coordinates. For this one, I didn't have to do midpoint formula at all because what I have here is a horizontal line. So you can just count it. It was 1, 2, 3, 4, 5, 6, 7, 8. The midpoint of this line is going to be 4. So I moved over 4. 1, 2, 3, 4. Right here is my intersection point, and those coordinates would be 2, 3. Now, if I did have to do the midpoint, I could say my S would be -2 plus 6 divided by 2. So that would be 4 divided by 2, which would give me 2. And 3 plus 3 divided by 2, which would be 6 divided by 2, which would give me 3. So that is my midpoint there. Okay, let's look at number 6. Number 6 says 3 vertices of parallelogram ABCD are given. Find the coordinates of vertex D. So the first thing you're going to do is plot these 3. Okay, so looking here, I have these 3 written down, and I plotted them in blue. Okay, here's A, B, C, D. So then to find the 4th vertex, I said, okay, how did I get from B to A? Because this is the line that's going to be parallel to this one. How do I get from B to A? So I said, well, I went up 2 and to the left 3. 1, 2, 3. So I come down here and start at C, and I went up 2 and to the left 3. And that's where I put my 4th vertex, and the coordinates there are 0, 1. Okay, so that is all for, let's see, that is all for this section. I want to briefly look at this worksheet here. and it is online in Google Classroom under the Accelerated Geometry, on the Accelerated Geometry Google Classroom page. There's also an online assignment for 7.1 and 7.2 in Big Ideas Math. So this is the one that's in Google Classroom. There's also a copy of the book in there under this assignment, so you can just pull both up together. You don't have to print the worksheet if you don't want to. You can just write it on notebook paper and then upload it into Google Classroom, or you can print it, fill it out, and upload it back into Google Classroom. Either one is fine. So let's look at these real quick to make sure everything is clear on how to solve them. So here it says, find the value of each variable in the parallelogram. So they tell us it's a parallelogram. So we know that opposite sides are congruent. So we know that 4x equals y, and that x plus 18 equals 3x minus 2. So 4x and y, trying to solve this isn't going to get us anywhere. So we can say x plus 18 equals 3x minus 2. We can solve for x. Then we can take x and plug it in up here to 4x, and that's how we can solve for y. On number 2, we have the same concept here. We have a y over 5 equals 4x minus 3. Well, we can't solve it as is, but we can solve our opposite angles. And we know that opposite angles are congruent in a parallelogram. So we can say 4x minus 37 equals 49. We can solve for x, take that x, plug it in over here, and then solve for y. On this one, since we know it's a parallelogram, we know that our diagonals are congruent. So we can say 2x plus 10 equals 4x minus 2. And 5y minus 16 equals 3y. A couple of things to note down here on this bottom section is right here, 68 degrees is referring to the entire angle, not to just one section. 68 degrees is this whole angle N. Down here, 59 degrees is only this one little angle it's sitting in. You can usually tell by whether or not they have a marker. So they have marked the entire angle in here and drawn an arrow for 68. The rest of it you should be able to solve. Let me know if you have any questions.